Hello, in this session we evaluate the action of heat on nitrates. Welcome. The action of heat on nitrates reveals a logical trend in the sense that when nitrates of highly reactive elements, namely the monovalent species like potassium, sodium, and lithium, are heated, they decompose to their respective metal nitrite forms and oxygen gas. In other words, when you subject potassium nitrate to intense heating, it is reduced exclusively into potassium nitrite and oxygen gas. The same happens with sodium nitrate. When heated, it forms sodium nitrite and oxygen gas. Therefore, we can say that the nitrates of highly reactive monovalent elements decompose into their respective metal nitrates and oxygen gas. What happens to the nitrates of the less reactive elements which are divalent? Well, the action of heat of calcium nitrate can give us a tip of what happens. When you heat calcium nitrate, it is reduced into calcium oxide, nitrogen oxide, and oxygen gas. This trend is true for other divalent metal nitrates, namely magnesium nitrate, zinc nitrate, lead nitrate, copper nitrate, and so on. And therefore, when we take magnesium nitrate as an example, we find that when you heat magnesium nitrate, it is reduced into magnesium oxide, nitrogen oxide, and oxygen gas. What this shows is that the nitrates of divalent elements decompose on heating into their corresponding metal oxides, nitrogen oxide gas, which is a brown gas, and oxygen gas, which is a colorless gas. And that is the trend. However, when it comes to lead nitrate, even though it undergoes the same process, when you heat a lead nitrate, it decrepitates, forming a crackling sound in the process, and becomes wrinkled, forming lead oxide, solid, and nitrogen oxide, brown gas, and oxygen, the colorless gas. The same thing would happen with the nitrates of the least reactive elements below copper in the reactivity stages. However, the product on decomposing the least reactive metal nitrates is that they are changed or transformed into their respective metals, not metal oxides. For example, mercury nitrate decomposes into mercury, nitrogen oxide, and oxygen gas. The same would happen with silver and gold. And we could conclude, therefore, that the action of heat on metal nitrates of the least reactive elements below copper in the reactivity series reduces them to their corresponding metals, nitrogen oxide gas and oxygen gas. And the unique property happens when you decompose ammonium nitrate. Ammonium has the tendency of reducing into ammonia gas. However, when you decompose ammonium nitrate, it is reduced exclusively into nitrogen oxide, otherwise known as the laughing gas, because it causes hysterical laughing when inhaled. It also leads to the formation of steam. Therefore, we say that when ammonium nitrate is decomposed by heat, it is reduced into laughing gas and steam. And this process exclusively represents the decomposition of the nitrates of elements of metallic form and cations such as ammonium. In summary, we have said that the decomposition of nitrates of highly reactive elements like potassium, sodium, lithium, and any other monovalent species reduces them to their respective metal nitrates and oxygen gas. We have also said that the decomposition of metal nitrates of divalent molecules reduces them into their respective metal oxides, nitrogen oxide gas, which is a brown gas, and oxygen gas. And finally, we have said that the decomposition of the least reactive elements in nitrate form reduces them to their corresponding metals, nitrogen oxide gas and oxygen gas. Conclusively, we have looked at ammonium nitrate, which we have said is reduced into the laughing gas, nitrogen monoxide, and steam. Thank you very much.